So let's look at example 11 here. It says find g triple prime, the third derivative, evaluated at 1 for g of x equals x to the fourth minus x cubed plus 2x. Let's give this a go. Let's go ahead and find the first derivative of the function. Well, the derivative of x to the fourth would be 4x cubed, minus the derivative of x cubed is 3x squared. Again, this is using the power rule, plus 2 times the derivative of x, which is 1. So 2 times 1 is just a 2. There's the simplified version. From that, we can find the second derivative. The second derivative would be 4 times the derivative of x cubed, which is 3x squared. So 4 times 3x squared would give us 12x squared. Notice I'm doing some simplification, kind of doing 2 steps in one here. Minus 3 times the derivative of x squared. Well, the derivative of x squared is 2x. So minus 3 times 2x would be a minus 6x, plus the derivative of 2, which is quite simply 0. We move on to the third derivative. The third derivative, the derivative of 12x squared, is 12 times the derivative of x squared, which is 2x. And 12 times 2x would be 24x. Minus 6 times the derivative of x, which is 1. Minus 6 times 1 would be a minus 6. So our third derivative is 24x minus 6. We continue on to find the, that's what we wanted, was the third derivative, except we wanted the third derivative evaluated at x equals 1. So let's go ahead and plug in 1 into this function. This would be 24 times 1 minus 6. Well, 24 minus 6 is 18. So our final answer here should be 18. Okay, let's look on to the next one. It says find the fourth derivative of y equals 1 over x squared. Find the fourth derivative of y equals 1 over x squared. Well, again, what I want to do is write this in exponential form where the x is in the numerator. So I'm going to have x to the negative 2 is how I think of my original function. Okay, so what would my first derivative be? Well, my first derivative would be drop the power, which would be negative 2x, to the power minus 1, which would be negative 3. Now, if this was my final answer, I would need to simplify this, but this isn't my final answer, so I'm not going to simplify it until the very end. Let's find the second derivative. So the second derivative would be negative 2 times the derivative of x to the negative 3. Well, the derivative of x to the negative 3 is negative 3x to the negative 4 using the power rule. So negative 2 times a negative 3 would be a positive 6x to the negative 4. Let's go ahead and find the third derivative then. The third derivative would be 6 times the derivative of x to the negative 4. Using the power rule, the derivative of x to the negative 4 is negative 4x to the negative 5th. So 6 times negative 4 would be negative 24, and then we'd have x to the negative 5th. So this asks for the fourth derivative. We've only got one more to go. Let's go to the fourth derivative here. So we'd have negative 24 times the derivative of x to the negative 5. Using the power rule, the derivative of x to the negative 5 would be negative 5x to the negative 5th. So we'd have negative 24 times negative 5, which would be positive 120. And then we'd have x to the negative 6. But remember, our final answers cannot have negative exponents. And since this is our final answer, we do need to put this back into with a positive exponent. So we would move x to the negative 6, throw that x to the 6 in the denominator. That 120 has to remain in the numerator. So I'm ending up with 120 over x to the 6. 120 over x to the 6. Okay. Let's look at the next one. It says find the second derivative of the following functions. The first function is x plus 1 over x minus 1. So if I want to find the first derivative, I'm going to be using the quotient rule. Quotient rule, remember, is the low, which would be x minus 3, times the derivative of the high. The derivative of x plus 1 is simply 1, minus the high, which is x plus 1, times the derivative of the low. Well, the derivative of x minus 3 is also simply 1. All over the bottom squared, so that would be x minus 3 quantity squared. Well, let's do some simplification here. X minus 3 times 1 is just x minus 3. And then x plus 1 times 1 is just x plus 1, but I'm going to distribute that negative, so I'm actually going to have a minus x and then a minus 1. All of this is over x minus 3 quantity squared. Notice in the numerator, my x's are going to cancel, and I'm going to be left with negative 3 minus 1 for my first derivative. Negative 3 minus 1 is going to be negative 4 over x minus 3 quantity squared. So here my numerator is negative 4, my denominator is x minus 3 quantity squared. So now I want to find the second derivative. The second derivative, again, I need to use the quotient rule. The quotient rule is the bottom, which is, x minus 3 squared. Oof, you guys can't find the derivative of that yet because that actually requires something called the chain rule. So what I'm actually going to have to do, even though I've said numerous times don't distribute out the denominator, for this example we're going to need to. So x minus 3 squared, quantity squared, FOILed out would be first, which would be x squared. Outer would be minus 3x. Inner would be minus 3x, so that would be minus 6x. And then a negative 3 times a negative 3 would be a plus 9. So that's what I'm getting for my first derivative of the function, negative 4 over x squared minus 6x plus 9. So what would I get for the second derivative? Well, the second derivative, again, I'm going to do low d high minus high d low over what's below squared, but for the first derivative. So the low function is x squared minus 6x plus 9. The derivative of the high function, well, the high function is negative 4, and the derivative of negative 4 is 0, so that term is going to go away, minus the high function, which is negative 4, times the derivative of the low function. Well, what's the derivative of x squared minus 6x plus 9? The derivative of x squared is 2x, the derivative of minus 6x is minus 6, and the derivative of 9 is 0, so that's what I'd have all there. All over the bottom, which would be x squared minus 6x plus 9 squared. So again, this first term is going to go to a 0. I'm going to be really careful here. I'm going to distribute a negative 4. So this is really a positive 4, right? So I'm going to do a positive 4 times the 2x and a positive 4 times the negative 6. Again, be extremely careful distributing the negative. So a positive 4 times 2x is 8x, and a positive 4 times negative 6 would be a minus 24. Be careful with your negatives. And on bottom, I have x squared minus 6x plus 9 quantity squared. So, or we could write this as 8x minus 24 all over, and this would be x minus 3 to the 4th power. The only reason I knew that was because before this denominator was x minus 3 squared, and so if I took x minus 3 squared and then squared it, x minus 3 squared would be x minus 3 to the 4th. So this would be the factored version. But again, I don't really care here. Any of these versions would work. So the way that I did it, I ended up with the x minus 24 all over x squared minus 6x plus 9 quantity squared. I'll leave that as my final answer on this one. Okay. Let's look at B here. G of x equals 3 sine of x. Again, it is asking for the second derivative of this function. So let's go in and find the first derivative of this function. The derivative of 3 sine x would be 3 times the derivative of sine of x. The derivative of sine of x is cosine of x. So now let's find the second derivative. Well, the second derivative would be the 3 times the derivative of cosine of x. Well, the derivative of cosine of x is negative sine of x. That gives us our second derivative, negative 3 sine of x. So what's the second derivative of 3 sine of x? The answer is negative 3 sine of x.